Okay, so today we will be talking about, or you'll be doing EDA. And when I say EDA stands for Exploratory Data Analysis, right? Exploratory Data Analysis is a crucial initial steps in one of the crucial initial steps in data analysis, right? When you are analyzing a data. Okay, so the purpose of this exploratory data analysis is to help you examine and summarize your data to understand its main characteristics, patterns, relationship, and then the potential issues, right? Yes. So EDA also help you to gain more insight from your data set, right? And also help you to identify missing values, outliers, trends, and so on, right? And also decide on appropriate pre-processing steps. So EDA is very, very important steps in data analysis. Okay, so we will talk about the common techniques in the EDA, which is the exploratory data analysis, right? So here one step is summary statistics. We also have another technique is data visualization. We can also talk about the handling missing values. I think handling missing value, we did that one yesterday. Can also talk about outliers detection. Can also talk about correlation analysis, feature engineering, data transformation, categorical variables, time series analysis, hypothesis testing. All these are techniques used in exploratory data analysis, right? So today we will look at some of them, right? We will look at the summary statistics, data visualization. I think the missing values, we did that one yesterday. And then also correlation analysis, and then feature engineering too, we did that one. And then data transformation. Yeah, so we look at some of them, right? Categorical variables. Yeah, we look at some of them today, right? So maybe next time we'll meet, then we'll continue, right? So these are the techniques in the exploratory data analysis. Okay. Any question? Okay, Emmanuel. Okay. I will share. Okay, sure. Okay, I will share the notes, right? Okay, I'll do that. And then as for the video, I'm not done editing the video. That's why I didn't upload the video. But the note there is available. I will share it right after you close, right? Okay. Any question on that too? Any question? Okay, so if there is no question, let's move to our first technique, which is the summary statistics. And then this techniques is used to compute basic statistics like mean, median, mode, variance, and so on, right? Yes, so to get an overall understanding of your data, that's where we use the summary statistics. Okay, so let me share my screen. me share my screen. Okay, good. Okay, so this is the data I have. Let me share the link with you, so that let me share this link in the comment section. Okay, so you copy it, then you run it. Okay.
Please, can I share the link again in the comment section?
Yeah, I've shared it. Check.
I just joined in my laptop. Share it again, so I can copy.
Okay. Okay, so here you said our first technique is what? The summary statistics. Okay, so let me run this one. Good. So this is our first technique, right? Okay. And let me make some small note here that this help compute basic statistics like mean, median, mode, and variance. To get an overall understanding of your data. Okay. Okay, so let's check. So when you have a data like this, normally we first check the what? We first check the description, right? So you have to describe. So describe your data. So this is the description about the data. So we have the count, the number of rows of each column, we have the mean of each column, the standard deviation of each column, the mean, the minimum, the maximum, the first percentile, second percentile, and then third percentile, right? Yes. Okay, can also talk about info, right? Info, the info. So this is the information too. The information give you how many entries, number of columns, the total number of columns, and then total entries. Okay, and also I'll give you the data types too, right? Okay. Are you on the same point? Am I moving faster or? Hello? Yeah. Okay. I think it's okay. So if you're okay, let's proceed. So here we can also check. We can also check, let's say, the mean of the column we have, right? Of each column. So let's take this column, the quality, right? Or the alcohol column. Okay, so first of all, let's understand this data. So here, let me search this so that you see. Okay. So let me share this with you. So I got this data from this website, right? This website is that's UCI machine learning repository, right? So you can visit this website, and then there's a lot of free data here you can use for practice, right? Yes, and all this data is a real world data set. So yeah, you can visit this website, and then you can download any data here. You search, can come to the data set, and then these are different data sets you get, right? Data set on mushrooms, right? We have car evaluation. There's a lot of data sets here. You can search here too, then you get different data sets, right? Yes. So I'll share the link with you so that anytime you want a data set, you come here, then you download some of the data set here. Okay. Oh. Okay, good. Here we can also look at the column, right? Let's check the mean of this column, the alcohol column, right? Check the mean of alcohol column and say alcohol. dot mean. Then here we are getting the mean of what? Of 10.91, right? This is the mean of the alcohol column, right? Yes. So here that's about the summary. This is summary statistics, right? This one techniques in what? In the exploratory data analysis. Okay. Yeah, Louis, do you have any?
Yes, sir.
Yeah, do you have any question?
No, sir. Please, I'm okay.
Okay.
If just a gentle recap.
You said?
Just a quick summary of what has happened.
You want me to?
Yeah, I see you are capturing summary statistics. I just need a quick recap of what has happened. Have you shared any new documents?
Oh no, we just started.
Okay.
Okay. So yeah. Okay, someone I shared it, so okay, so let's proceed. Let's move on to the next one. The next one is data visualization, right? Yes. So data visualization. Okay. Data visualization. Okay. So can someone tell me something about data visualization, a definition, or yeah. So what is data visualization? Any idea on data visualization? Oh, I asked you yesterday and someone said you have done data visualization. So any
okay. So when I give the data, to make it easy for somebody to read, to understand the data, you have to put it in the form of a table, whether a histogram, a bar chart, or a pie chart.
Okay, thank you. Who else?
I think it's a representation of data in a graphic presentation, such that it's easier to read, comprehend, and to analyze.
Okay, thank you. Who else? Okay, so as we said, data visualization is a graphical representation of what? Of a raw data, right? Yes. Now, this is data visualization is a technique in what? In the exploratory data analysis, right? Yes. Okay, so here we are coming to put this our data in the form of a visual, right? Okay. So let's start with histogram. Let's start with histogram. I hope you all know histogram. So far as I have done data visualization, that means you know something about histogram. So what is histogram? Let's understand the meaning of histogram. Oh, the histogram chart. Okay, so let me proceed. You understand it? Okay. Okay, so here let's start with histogram plot. Okay, so we are using the pandas, right? Okay, so we say PF, and this DF is the what? Is the name of what? That's our data, right? Our data frame. Okay, so we say DF dot hist into bracket, then we say column. Let's say we wanted to plot this alcohol column, right? The alcohol column on the histogram. Okay, so the column equals then the name of the column, which is alcohol, and then the intervals. We want the intervals to be what? To be 15. So we set to what? 1, 5. Okay. So now we are getting our nice histogram.
So can you go up a bit? Let me see something.
Okay. Okay. So now let's understand the histogram graph. This chart, the histogram chart. So here the histogram is a as we said, it's a graphical representation of a provided visual overview of a distribution of a data, right? So here the histogram display the frequency or the count of data points that falls in various intervals, right? And this intervals is called the mean. So this is the means here, right? Okay, so that's what about the histogram. So here, as we set the intervals to 15, and then give us the that's from the intervals, right? Okay, so here that means from 9 to what? From 9 to 10 have the highest distribution, right? Okay. Now let's add more function to this chart, this histogram chart, right? Okay. Let's add more function to it. So here, let me see the same histogram. Okay, let me copy the code here to this side, and then here I'll make the grid. This second one I want to off. I don't want this grid in it, right? So let me off the grid. So let me set grid to false. Grid to false. And then the colors let me set it to, let's say, green. Alright, okay, then let me run it. Good. So the same chart here, this is the same chart here, right? The same thing, but here I've off the grid and then also change the color of the chart to green, right? Okay. I can also change the how do you call it, the size. Alright, so let me say figure. If I want to change the size, say figure size equals, let me say 12 and 10. Good. Now it's look big, right? Okay, I think it's too big. Let me reduce it to, let's say, let me do it 10. Okay, so let me reduce this side to, let's say, 8. Okay, right. Okay. So here you see that our plot look nice, right? Now, but let's use Seaborn, right? Seaborn library, and we can, the Seaborn library will make our chart more nicer than this one, right? So here let's import the Seaborn library. So import Seaborn as SNN. Okay. So here we are using the Seaborn to do or to plot the same charts. Okay, so okay. So let me say SNS dot this display plots, right? The inside it, I'll pass the DF. Okay. Then I'll say the mean equals, let's say 25, right? Okay. Okay. Let me off this one here. False. Okay, so this is using histogram. Sorry, using Seaborn. Right, this is using Seaborn. Okay. So here we use this chart. We use Seaborn to do or to plot this chart. Right. Okay. So let me copy this one here. Let me cut it and paste it this side. Then here too I can import. Let me import one more thing. Import matplot lib py plot plt. Okay. 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 Are you on the same point?
Please go to where you imported the math plus at the top there.
Top here. At the top there, okay.
Yes.
Yeah.
Please stay there small. Okay.
Okay, are you done?
So I can proceed.
Okay. Okay. Also, you can also talk something about scatter plot, right? Yes. Also talk about scatter plot. Using the seaborn. Okay. So let's do the scatter plot. So x equals to, let's use the same alcohol column, and then so y equals, let's say fixed acidity. So let's go back here and check another plot we can use for the. So here, let's use this one, the fixed acidity and the y, right? So this one will be, the alcohol will be on the x-axis, and then the fixed acidity will be on the y-axis, right? Okay. And then we say the data we are using is what? We are using the DF data. Okay. So now this is our scatter plot. Very simple scatter plot we have, right? So here, this is how the point has been scattered, right? Yes. Okay. We can also use the same scatter plot for the same alcohol and then the density. So let's move top and check the density. Okay, so this is the density here, right? This is the density column. So let's make the density column at the y-axis, and then the same alcohol on the x-axis. Okay. So let me come to down here, and then
Please, I got attribute. Okay, be here for me. I'm coming.
Okay. Attribute error. So let me check density. Okay. So this is the density column. So this is how the point has been spread, right, on the density column. Okay. So here, the process of doing all these things is to what? Is to help us understand the data, right? Check the how do you call it, the characteristics, and also understand the relationship and patterns, and then the potentials issues, right? Yes. So that's the main purpose of we doing this, right? Okay. Okay. Are you okay? I hope I'm not. Okay. I hope I'm not moving fast.
Yeah,
Yes, let me check. Okay. And I got import. I'm told import is an attribute error.
Import is what?
It's capital I.
No, it's not I. It's L.
Oh, okay.
LM plot.
Okay.
Okay. Okay, that's good. We are fine. Okay. Now let's move to the next one. We are still using the LM plot, right? So SNN dot LM plot, and then we have X, the same X. Let's use alcohol, right? So alcohol, and then Y equals chloride. Let's use the chloride for Y. It's chloride, and then the data we are using, the data is what? Is DF. Okay, but let's put the regression line of this time around. We don't need the regression line, right? So let's put the regression line off. Okay, so false. Then legend, let's make the legend equal to the quality. Okay. Or the error says regression chloride. Okay, the spellings of the chloride, let me check here. Okay. The spellings. Okay, good. Right, this Ludwig, can you mute yourself? Okay, so this is the scatter plot we have. Okay, okay. I hope you are on the same point, right? Are you on the same point? Okay. Okay, so have you heard about box plot before? Box plot. Hello. Hello, I'm asking a question. Box plot. Okay, so here box plot is a visual that distributes a data set and identify potential outliers. So we use the box plot to identify outliers, right? Yes. That's the I mean how the points are divert or deviate from the normal plot for other plots, right, or other points. That's what we use the box plot to check. Okay. So let's plot our first box plot. Now let me show you one thing here. Let me show you one thing here about the box plot. Show you one thing about box plots. Okay. Okay, so this is the box plot. Okay, so this is the box plot, right? So here when you plot a box plot, then you see a point beyond the maximum. So we have the maximum and then we have the minimum, right? You said that all the points should be falls between this, right? So all the points here are called outliers, right? This is an outlier point, right? Good. And then we have the odd. We have the first quarter, the odd, the median, and the third quarter. Then we have the maximum and the odds, and then the outlier, right? So when you plot a box plot, then you find out that there is a point above the maximum. That means what? That point is what? Is an outlier. Are you good? Okay. Okay, so let's so if you look at this one is what? This one, all the points are what? There's an outlier. All these points are outliers, right? Yeah, all these points are outliers. Okay, and this one too, we have this one here. Yes, so here, yes. Okay, all these points are outliers. Okay. Any question on this? Any question on this? Hello, can you hear me? Okay.
Yes, sir. Yes, sir.
Okay. 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 Okay, so let's plot our box plot, right? So here I will make a comment here as box plot. Okay, so we just use SNN, that is seaborn, to plot our box plot. Okay, so you wanted to check the outliers in the alcohol column. So alcohol. Okay, so here this is the outlier. Then we said that we found one outlier here, right? Okay, so yeah, let's also use let's add multiple multiple columns in our box plots, right? So let's add let me create a variable called summary, and then let me drop some of the columns, right? So let me drop this. Let me drop these columns. Free sulfide, dioxide, then total dioxide. So I'm dropping some of the columns in the data frame, right? Yeah, I'm dropping some of them in there. So I'm dropping this one, and then this one too, and then this one. After that, I'll plot the rest of the plot on the rest of the column on the box plot. Okay. So, and then also the quantity. Okay. Then let's drop this one to the residual. The residual sugar. And then the fixed acidity. And then the last one, let's drop alcohol. Okay, let's drop alcohol. So let me bring this one here. Let me end it. And then we have to specify where we are dropping it on the say axis equals 1 because it's the column section. Okay. see what the error says. Sulfide does not exist. Bring it somewhere here. Total sulfide. Okay, so let me check the spellings of the okay, so this is the total sulfide. Okay, and then another one, see what? Okay, quantity, remove the key. Okay, good. Then now you can use the plot the rest of it. So dot box plot. Equals to set 3. Okay. What else? Let me check the error. Okay, so let me change here. Okay. What I wanted to do, it's not giving me the right thing. I'm coming. Let me figure out the errors. Okay, I'm coming. Let me add. It's not valid name. Okay. Okay. Fine. So this is what I wanted to do, right? Okay, so this is what I wanted to do. So here I deleted I deleted all this one from the data frame, right? Then I give it a name, summary. Okay, then I plot the rest of the plots. So I plot the rest of the columns, right? Okay, so when you take this one, there's the HP. So here this is the box plot for HP. When you take the density, this is the box plot for the density, then the chloride, then citric acid, and then the rest, right? Okay. I hope you are on the same point. Are you all on the same point? Yeah, hello. Yeah, Samuel.
Okay, I think I have an attribute error.
Is that what?
I have an attribute error. The C1 has no attribute called box plot. Let me check it too.
Oh,
okay, I've seen it. I've seen it.
Okay, thank you. Okay, and who else? Sandra, I hope today I'm not moving fast.
No, please.
Oh, okay. Okay. So now let's move on to bar. Let's move on to bar. That's a bar plot. We are familiar with bar plot, right? Hello. Are we familiar with bar plot? Okay. Okay, so let's move on to bar plot. So here we are using the same SNN, right? That's the C1. C1.count. Now using the count plot. Then X equals to then we said the data we are using is what? We are using the DF, and then we say the how, that the legend equals to type, right? Okay. Okay, that's the type. Okay, so we are plotting the quality. The quality. So here when you take the red, all the blue stand for the red wine. The blue stand for the white wine, and then the red stand for the red wine, right? So we're comparing this, we can see that the white wine is what has a more, like it's more quality than the red wine, or the amount is what, that's the number of red wine is what is more than the number of white wine is more than the number of red wine. Okay, so that's why we can use the count plot. Okay. Okay. Any question up to this point? Okay. Okay, so let's move on to one step, which is one technique, which is the correlation, right? Okay, so we can set correlation. Okay. Okay, so this is a correlation. So what did we say about correlation? Okay, so we said that correlation calculate the relationship between the variables, right? Calculate the relationship between the variables. Okay, and then also the independencies. So here the same columns has been arranged in the form of row and then in the form of column, right? So here there's more in this correlation. Now correlation is how the one variable affects the other, right? How one variable affects the other. So here to change. So here when you take, let's say, fixed acidity here, we have fixed acidity also here, right? Because there is the same thing. There is a fixed acidity here. By all means, it will be 1. So we also have types of correlation. We have a positive correlation, negative correlation, and zero correlation, right? Positive correlation means it has a higher. Okay, let me show you this slides. Let's talk more about this correlation. Let me show you this slides so that you understand the term correlation.
Hello, please, are you recording?
Yeah, I'm recording.
Okay.
Please, will you share this recording as well?
Yeah, I'll share it. Yeah. Okay, let me show you this. Okay, this is the correlation I'm talking about here. Okay, So here, correlation measure the statistical relationship or association between two variables, right? It describes how changes in one variable are related to change in another variables. Correlation does not imply caution, meaning that a correlation between variables does not necessarily indicate that one variable cause the other variables to change. So here, types of correlation, as I was talking about, we have the positive correlation, negative correlation, and zero correlation. Right. Okay, so in positive correlation, the variable move in the same direction. When one variable increases, the other variable also trying to increase, and vice versa. For example, there may be a positive correlation between hours spent studying and exams score. So here, when you take this example, hours spent studying and an example. So here the correlation is positive, because if you spend more time studying, that means you get a higher score, right? When you reduce your time studying, you get a lower score. So you can see that the hours spent studying and then the exam, it affects the exam score. It has influence on your exams, right? The more you study has influence in your exam score. And then the same thing applies to the negative correlation. So in negative correlation, the variables move in opposite direction. When one variable increases, the other variables trying to decrease, and vice versa. For example, there may be a negative correlation between the number of hours spent watching TV and physical fitness level, right? Yeah, so you see that here, watching television has nothing to do with physical fit level, right? Yeah, so here that means that there is opposite. There's opposite, because when you spend more time watching TV, doesn't affect anything on your fitness, right? Okay. And then the zero correlation indicates no relationship between the variables. Change in one variable are not associated with changes in the other variable. It is important to note that zero correlation does not imply independency. Two variables may be related in a non-linear or complex manner, even if there's a correlation coefficient is close to zero. So here, higher correlation, when you have one correlation is measured between that from 0 to 1. If you have zero correlation, that means there is no correlation between two variables. And when you see negative correlation, you see that the variables is moving on opposite direction, right? And you see positive correlation, let's say 0.1 or 1, or positive any number from 0 to 1. When it is positive, that means there is a positive correlation. Okay. Are you okay with the correlation? Hello? Hello? Okay. So now we can I proceed? Hello, can I proceed? Okay. Yeah, that's a similar thing to this one, right? So here, so when you take the fixed acidity and then the volatile acidity, you see that we have a positive correlation, right? And then the correlation is 0.220172, right? So this that means there's some correlation between the fixed acidity and then the volatile acidity, right? The same thing applies to the acidity, fixed acidity and then citric acidity. That one too is a positive correlation. When you take the fixed acidity and then the residual sugar, you see that it doesn't correlate it because it's negative, right? Here there is no correlation between this and this one, right? But we take the chloride and then the fixed acidity, there is a correlation between it, right? Yeah, so we use, that's all about the correlation. Now we can put this correlation in a heat map, right? The same this thing, we can put it in the heat map. Okay, so let me use the CNN.heat map, right? Then I will say correlation. Okay, so this is the in the form of heat map. Now let me set the annotation. Annotation equals true. Okay, so this is in the form of heat map. The same this correlation here, I've put it in the form of heat map. So let me increase the size. Not figure. Let me increase the size. Figure size. Okay, so yeah, I've increased the size. Okay, so this in the form of heat map, right? You see, this is more, more readable than this one, right? Yes, so this, but everything is the same. The idea is the same. This is in the form of raw, and this is in the form of what? In the form of map. That's the heat map. Okay. Okay. Any question on this one? Any question on this one? Hello. Louis, are you there?
Yeah, please, for the x-axis part of you see where the x-axis has been labeled in the heat map.
Yeah.
Is there a way to rotate the right in using, or for this one is fixed?
Rotate like how?
To make
the axis, the inscriptions a bit rotated. You know, usually in the axis you can rotate, put a rotation on the labels.
Why yours has been what? So here in the heat map,
I'm looking at yours. Yours is
vertical, right?
Yeah.
In the x-axis, yeah. Can you slant it a bit in heat map?
Like breaking the labels, right? Rotate it in the form of what? 90 degrees, or this is in the form of 90 degrees. So you wanted to move it to, let's say,
90 degrees, yeah.
So let's
So maybe 75 or 60.
That won't be the best. Heat map, normally the axis is fixed, unless maybe the label is too long and you wanted to break it, right? If the label,
Okay.
if the label is too long and you wanted to break it, that one is fine. But you rotating it won't be the best, because if you rotate it, maybe it can appear when you take, let's say, the quality and you are rotating it, it can mix up with the alcohol label. But if it is long,
I mean, when we apply it to all equally, so they'll all be like uniformly slanted. I'm just asking if you can apply it in heat map.
Oh no,
because it's in the other. Okay.
But if you wanted to break the label, that one you can do that one.
Oh, okay. Demonstrate it if you can.
Okay. Okay. Any other question? Okay. Now let's move on to the next one. Okay, I think that one we have done feature engineering, right? And then the handling missing data. Yes, so here that means we have done almost all the techniques in the EDA. But I want us to talk about time series analysis. But that one, unless we cannot talk about time series analysis here, unless we take time series analysis as a full topic on its own, right? Then we talk about it. Yes. If you wanted to talk about it related to the exploratory data analysis, it won't be best. So there is more into the time series analysis. So I think Theo will take you through time series analysis when it comes.
That's on Monday.
Yeah, I'm not sure. Like, I'm just saying it, right? I don't know the full curriculum, right? I'm saying if maybe Theo will take you through time series analysis. Yeah, I'm not saying.
So I think next week is our last week, right?
Next week is your last week.
Next week is week 6.
Week 6. Okay.
Oh, my room.
I think week 5 or week 6.
I thought next week was week 6. So.
I think week 5.
Okay.
So how many weeks are you spending?
6.
6 weeks, right? Okay.
Yes.
Okay, that's fine. Okay. So here today I was like, let's do something practical. Have you solved anything doing some project on what we have done so far?
No, you learned the last week we did projects. In the last weeks.
Last week we did project.
I mean that we were told that we will do project during the last week.
The last week. Oh, okay. So that means, yeah. Okay, so this is all about the topic of the day. I'll send you the slides. I'll prepare the slides on the the exploratory data analysis and then sent it to you, right? But I'll send yesterday's own right now, right? Okay.
Okay, sir.
Okay, sir.
Okay.
Thank you.
So
All
if
right, thank you very much.
so if there is no question, I have to do one or two things. So sorry for the today we didn't spend much time, right?
Today, I see that our numbers are not as high. Yeah, so our numbers are few today.
Yeah.
We are about eight.
Friday people make busy, so
Traffic data will not be easy.
okay. So let's end here and then continue the next time, right?
All right. Okay, thank you, sir. Bye bye.